In the previous video, I explained about subnet masks which are on class boundaries and a very small example of variable length subnet masks. And in this video, I am going to show you how to create subnets using variable length subnet masks. So this is a class A network, and the network address we have here is 10.0.0.0. And the default subnet mask of a class A address is 8 bits. So here I have marked 8 bits in blue color and rest of the bits in yellow color. That means these blue color bits are the network bits and these yellow color bits are the host bits. So if we consider the network mask, how we calculate network mask is we have to turn all the network bits into ones and then we have to take its decimal value. So here I have 8 network bits. Therefore, if I turn all those 8 bits into ones, I have the decimal value 255. So the subnet mask in this case is 255.0.0.0. That means the default subnet mask of the class A network. In this case, I have not taken any bit from the host side. Therefore, I have no subnet bits. And therefore, I don't have any subnets in this case. But I can have hosts with these host bits. That means I can have 2 to the power 24 minus 2. I think you already know that minus 2 means the broadcast address and the network address. And if I move into next example, here the network address is same but the subnet mask is 9. That means I have taken 1 bit from the host side to the network side. And here I have total 9 number of bits for the network sides. That means if I want to calculate the subnet mask of this network address, what I have to do is I have to turn all these network bits into ones and take its decimal value. So we know that when we write dotted decimal notation, we have to consider 8 bits at a time and then we have to take its decimal value. So if we take the first 8 bits, when we have ones for all 8 bits, the value is 255. And when we take the second octet, that means second 8 bits, here I can have another value. For the network address, I have to mark network bits as 1. So here this red color bit is belong to the network side, therefore that should be 1. That means here 1 and 7 zeros means 128. I think it is clear to you. When we want to calculate the subnet mask, what we do is we have to convert all network bits into ones and take its decimal value. So for the first 8 bits, when I turn it into ones, there are 8 ones. That means the value is 255. And for the second octet, if I turn this network bit into 1, then what we have is 1 and 7 zeros. That means the value is 128. So here I have taken 1 subnet bit and the number of subnets I have is 2 to the power 1. That means 2 subnets should be there and rest of the bits of this 32-bit address can be taken as the host bits. So therefore, the number of hosts I have in this case is 2 to the power 23 minus 2. This 23 means one has taken to the network side and then we have 23 more bits for the host side. And we have 2 subnets here. So if we want to identify what are those subnets, this is how we do. The network address remains same all the time. So here I have 10 point and again for the second case also I have 10 point. And we know that for the network address, we have to make all host bits 0. So here, what are the host bits is, these yellow color bits are the host bits. So if I keep this 0, the value will be 0 and 0 for the last 2 octets in both the cases. And what happens in this case for the second octet is, from the second octet I have taken 1 bit for the subnet, and therefore the value should be calculated for that octet. So if I have 1 bit, that means I can have 2-bit patterns for that. That means if I have 0 for this bit, I have 1 pattern, and if I have 1 for this bit, I have another pattern. That's what I have mentioned here. Here if I have 0, I have this value, that means value 0, and if I have 1, I have value 128 for the second octet. So therefore, the subnets we have is 10.0.0.0 subnet and 10.128.0.0 subnet. Let's see another example. In this example, again I have taken the same network 10.0.0.0 and I have 10 bits for the subnet mask. We know that class A has default 8-bit network mask which is marked in blue color, and these 2 red color bits are the additional bits I have taken for subnets. Here I have 2 subnet bits, that means I have 2 to the power 2 subnets. So therefore I have 4 subnets here, and when we change the pattern of these 2 bits, I can have 4 patterns: 0 0 pattern, 0 1, 1 0 and 1 1. So according to that pattern, the value we have for that second octet changes. So here in the first case I have 0, for the second case I have 64, and for the third case I have 128, and last I have 192. And when we consider the hosts, here I have only 22 bits for the host side. Therefore, the number of hosts I have in this case is 2 to the power 22 minus 2. And if you want to calculate the network mask for this subnet, again what you have to do is you have to turn all the network bits into ones and then convert it into decimal notation. And here for the first octet, if I turn it into ones, I have 255, and for the second octet I have 2 network bits, and those 2 network bits will become 1, and rest of the 6 bits will remain as 0. That means the last subnet is similar to that of the network mask. And now I have a class B network, and here I have 16-bit net mask. This is the default network mask for class B network. So I have 16-bit for the network side and 16-bit for the host side. And again, I haven't taken any bit to make subnets. Therefore, in this case, I do not have any subnetworks. In the second example for class B, I have the network address 172.16.0.0 and the network mask is /18. That means I have 18 bits for the network side and 14 bits for the host side. And here I have taken 2 bits to make subnet. So we know that the default subnet mask is 16. That's why I have marked this first 16 bits in blue color. That means the default subnet mask. And these 2 red color bits are the bits which I have taken to create subnets. So here again 2 subnet bits means 2 to the power 2 number of subnets. That means I have 4 subnets. If you want to calculate the subnet addresses, how we do is we have to keep the network bits as it is. That means 172 0.16 remains same, and the third octet changes according to the subnet bits I have taken here. So I have taken 2 bits from the third octet, and if I change the pattern for those 2 bits, I have 4 different patterns, 0, 0, 0, 1, 1, 0, and 1, 1. And according to that pattern, if I calculate the decimal values for that third octet, I have these values 0, 64, 128, and 192. And therefore, your subnet addresses will look like this: 172.16.00 and 172.16.64.0, like that. And here I have not given a class C address example, so it's also similar to this. There you have 24-bit default network mask. So remember that you have 24-bit default network mask for class C, and thereafter, according to the number of bits you are taking into your subnet, you can calculate the subnet addresses of your network.